Good afternoon, everyone. On behalf of Confederation of Indian Industry, I welcome our distinguished speakers and all participants. I sincerely hope each one of you is following the social distancing discipline and keeping safe and healthy. As we are all aware, COVID-19 is spreading rapidly around the world and has significant impact on businesses. India is no exception, and with a long lockdown and resume of work in phases, the challenges for the individuals, governments, and industries are only multiplying. The current pandemic has once again highlighted the important role played by technologies. The pandemic has accentuated the promise of emerging technologies and use of advanced analytics tools to help address some of the critical issues and make it more efficient, effective, and accessible. The use of emerging technologies has shown tremendous promise across a broad array of applications. However, most of the individuals and industries are not yet familiar with the concept of AI. While there is a realization that AI has a considerable potential for altering business processes, but it is yet not clear how AI could be deployed for their sectors. Keeping this in view, the webinar on how AI is fueling Industry 4.0 is organized in partnership with Amplo Global. The webinar will highlight on the potential AI hold for different domains while also giving audience an opportunity to ask their queries. And to deliver the same, we have Mr. Navaneeth Seshadri and Ms. Pooja Soni for Amplo Global. Before I hand over the webinar to Mr. Navaneeth, I would like to give a brief introduction about our first speaker, Mr. Navaneeth. Mr. Navaneeth works as a Chief Technology Officer for Amplo Global Incorporation. Nava is a recognized visionary committed to inspiring insights, forging innovative solutions, and encouraging the implementation of new business strategies. He's a respected supply chain, manufacturing, and integrated business planning process leader with extensive experience in automotive, high-tech semiconductor, industrial manufacturing, and retail industries across North America, as well as the EMEA and APAC regions. A focused designer and an astute technology architect, he has been instrumental in the development of Amplify 4.0, his company's AI-based cloud product that is quickly revolutionizing the digital strategy initiation and tracking space. His 18 years of cross-cultural, cross-industry expertise have honed his focus on achieving innovation through digitalization using AI as a powering edge. During today's session, Mr. Navaneeth would discuss specific industry metrics in relation to AI and Industry 4.0, followed by an end-to-end illustration of how AI is enhancing the CAD world of part designers. He will offer critical success factors that industries have to take note in order to succeed in their initiatives, AI initiatives in their Industry 4.0 journey. Now, without taking further time, I request Mr. Navaneeth to kindly start the webinar. I also request all the participants to keep their mics on mute and unmute while speaking, and all the attendees can pose their questions in the Q&A or a chat section, which will be addressed at the end of the session. So now, with this, I once again request Mr. Navaneeth to kindly start the webinar.
Thank you, Rachna. So, good afternoon, ladies and gentlemen. Welcome to the CII webinar with Amplo Global. So, I just wanted to start today acknowledging the fact that we all have something common between us, right? So, the first thing that I would say in the Industry 4.0 and the AI topic that we are trying to discuss today, the commonality is that we all want to thrive for excellence and efficiency. So having said that, let me begin with explaining what really Industry 4.0 really is. So the Industry 4.0 is nothing but a merger between the physical and the digital world, using data and connectedness as the central piece of it to achieve analyzed industry data for getting data insights. So basically, the analyzed portion of the data comes from the AI piece of it. So you're making business decisions, looking at the analysis being done, So this is how the synergy between Industry 4.0 and the AI as a buzzword actually comes in play. So those are actually not separate, it just feeds into each other. Having said that, in order to run the analysis and then put together the data in for data insights to be provided, you need a lot of data to be first available in the market. And that's why data is such a critical component, and it's the new oil. So basically, data is so critical that it is the essence of the entire artificial intelligence and all the insights that you get, but it's abundantly available and not all the data are relevant. So you need to have a filtering mechanism to actually filter out and take away the data that is redundant and only make sense out of the data that actually is used for business decisions. So that's a hard part. And that's where comes the AI ops and entire transitioning of your IT operations with automation. That's where exactly the data filtering, the data strategy aspects of it comes into play, which is a key essence, which is required for Industry 4.0. So when this is being done, you need a cloud architecture and infrastructure to make this all happen, because data magnitude and velocity, the veracity is so much high, and the volumes are so high that it cannot be stored on a single PC like it used to be in the 70s or 80s anymore. So you need a large cloud infrastructure to actually store the data and then run the analytics on top of it using the AI. It requires a lot of backing from the technology stack. This is where the cloud-based platform comes into play. And integration with different silos of the organization has to happen to get rid of the silos, bring the data in from different places, and then make sure that everything is on the same platform to render insights based on analytics. So when this all has to happen seamlessly, it's in a sense meaning that the people in the company who are running the show for getting this live have to be empowered, and they have to make self-directed decisions. It is not that a third party comes in, gives you the consulting advice, and then they just go out and the people are clueless as to how they have to proceed from there on. So this is a very important intimation that I would like to make for any success of Industry 4.0 application using AI. The critical component are the people more than anything else. So having said that, let me just take you through how our Indian CXOs are actually talking about AI, what they really say. And in relation to the worldwide CXOs standard, there was a survey conducted. And based on that, the light blue numbers that you see are from the worldwide CXOs, and the dark purple numbers are from the Indian CXOs. So having seen these numbers, it is very clear and apparent that India is not laggard in AI space at all. So 79% of the CXOs really mean AI actually changes their business growth objectives and lets them achieve that. More importantly, being a laggard is absolutely a no in the current market situation, because there are some studies which also prove that the early runners into any AI technology reap the maximum benefits. Up to about 40% of digitization rate, you will have digital attackers who take about 15% of your market share. This is what the survey is talking about. And beyond the 40% digitization, if you spread and diffuse your AI across the entire enterprise, you are going to be making more profit than your industry average by large margin. So that is why 80% of the CXOs from India say that in the next 5 years, if they do not adopt AI, they are going to be out of business. And they have understood it more than the other global leaders. So that answers this. And of course, everybody acknowledged one fact. AI implementation is not about just piloting. Once you pilot, it is very important to scale it up. And when you scale it up, that's where the challenges come. And that's where actually you have to spend more information and more thinking how to mitigate the risks that will happen. If you look at the profit margin across different industry sectors, when AI is diffused across different departments in every industry, there is a lot of profit that you can expect. So the zero line you can consider as the industry average profit. So this was one of the another studies that were done. And if you see, there are industries from energy, automotive, technology, finance, telecom, and construction. It's not necessarily manufacturing that reaps the benefit out of the AI. And among all these industries that were surveyed and the stats were collected, if any company has across the enterprise AI diffusion done, energy sector reaps the maximum revenue, maximum bang for the buck, as you see in the first part of the diagram. and followed closely by fintech or the finance industry. Construction, although they can adopt a lot of AI technologies, and if they diffuse it completely towards the end-to-end construction process, they are still going to be ahead of the game from their market averages in terms of profit, but it's not as comparable to the energy. It doesn't mean they are not profitable. They are definitely profitable. On the flip side, if you see that in the third bubble, when there is no AI diffusion and it's limited digital intensity, which is most companies what they do, they adopt AI for specific departments. And when they do that, that's when the problem starts, because you have invested all your energy, people time, and then infrastructure and the cost. And for you to return or get your ROI, it takes a lot of effort from there on, because that is not sufficient. That's when, at that point is when your profits actually drop. And in order to mitigate that, you need to go all the way and become the AI power user, which is what the entire diffusion talks about, and you become profitable beyond the market average. It is not that your profitability reduces doesn't put you under loss, but it is something that is a short time frame during which the progression and maturity has to happen. And there is a lot of improvement that a profit can make once everything is diffused. So this is the curve that we will all have to learn. Looking at how individual departments in any company can be digitized or AI can be adopted, and how does it impact the revenue growth and cost reduction, this survey or this study that has been performed talks about different departments, including sales and marketing, supply chain manufacturing, supply chain management, and then even human resources, right? Anywhere, wherever they have adopted AI, there is a revenue growth. There is a lot of cost reduction as well. It varies from department to department, but net positive it is. So when you see this, you can observe closely that sales and marketing, when you adopt AI for those departments, you will see maximization of revenue most of the time. And least adopted today, based on several statistics, is in the manufacturing. AI is least adopted with the perception that investment is heavily required. It's not actually the case, but that's where you have the maximum cost savings if you really adopt AI. So why we actually say this? It's not just manufacturing. It's all across that you see a lot of revenue and revenue growth and cost reduction. For this, you will be taken through several use cases today. I will hand over to my colleague Pooja, who will take you through certain other industry use cases. And then I will cover one of the CAD use cases for you to understand how exactly this will materialize. So I hope you get a good takeaway today. Thank you. Over to you, Pooja. Thank you.
Thank you, Mr. Navaneeth. Before you give it to Pooja, I'll give a brief introduction for her. In fact, the details you gave was quite insightful, and I think infrastructure, data infrastructure is one of the very key important things that everybody has to really be vigilant about when they're planning their digital transformation and bringing technologies in their organizations. So now, without taking further time, I would like to introduce our next speaker, Ms. Pooja Soni. Pooja Soni is the Vice President of Strategic Services and Solutions at Amplo Global Inc. She has 2 decades of hands-on experience developing solutions in a broad range of business areas, executing complex projects, and delivering engagements that impact the bottom line. She is passionate about increasing value by driving change, improving operational efficiency, and delivering 4.0 solutions. Focused on the impact of predictive analysis, cognitive automation, and AI-fueled digital transformation, Pooja is an influential thought leader. Pooja today would bring forth the applications of AI in various business sectors. She will touch on how these applications have innovatively brought in efficiencies and new opportunities of doing and managing businesses. With that, I now request our next speaker, Pooja, to please start her delivery.
Hi. So, artificial intelligence. It is, can I get the control, Rachna? Thank you. So, artificial intelligence is the next technological giant leader, which is taking industry all over the world by a storm. So, it is compared to electricity or internet. So there are various applications of AI, and the first one we think about is economic. But also, apart from economic, it is also touching the social fabric. And we will walk through of how it does that. It has deep, wide applications in various industries, and we will walk through it. It touches manufacturing, which we typically think of Industry 4.0. It touches healthcare, it touches education, agriculture, etc. Now, when you talk about AI and its implementation, so what India has is a talent of we are gifted with technology. We do very well with technology. And we've shown in the past 20 years of how we've delivered technological solutions for companies which are based all over the globe. And what is also happening with the advent of AI, we've picked on to those. We have in-house deep knowledge on AI. And not only that, we have already started adapting those into our industries. So the awareness is so high that very recently, our Prime Minister, Mr. Narendra Modi, he introduced, declared Race 2020. So basically, it is responsible AI for social empowerment. So there is a lot of potential. Everybody is realizing it. And what it will help us with is be prepared for adversity, be prepared for innovation, be prepared to be ahead of the world market. Now, when we talk of AI, what lies at the root of AI or the center is data. As Nava said, data is the fuel for Industry 4.0. In fact, I would even say it's a new currency. So what I'm going to do now is walk through a few use cases, highlighting some of the relevant, important work that is done within the Indian space particularly. And as I walk you through, I would request or ask each of you all to have a thinking cap and see how AI and their solutions could be implemented on your industries. So in the last 20 years, we have started developing, and our government focus is very much on infrastructure. We are upping our infrastructure, whether it is roads, whether it is expressways, whether it is subways, metros. And through our advancement, we have seen that AI has started coming into play, and it has really helped with the infrastructure. So AI plays a role in 360-degree optimization. And to present that, we'll walk through the few very key components where AI has placed a considerable role. The first is geospatial constraint planning. So what happened? India kind of has grown organically. The city started developing as it wasn't really planned. As it came, we started growing. So what has happened from a geo perspective, that underground, you would find various pipelines, you would find internet cables, electric cables, which were kind of laid as the need arose. It was really not planned. So what happened is we had a little delay when it came to work. And now where AI is making a difference is where these data on these geo elements are started to be monitored and tracked. So now if you look at Bombay, we are looking at end-to-end connectivity of metros. So when we do that, we have started recording, and we have started using AI to see what should be the optimal plans for building the metro, what should be the optimal lines. And what this empowers the organizations, the various vendors who are working on the metro project, is they can do very accurate guesstimates. They can do, good analysis of when it would be delivered, cost, and quality and time. So that would be geospatial constraint planning. The next planning, which AI has really helped with, is resource utilization. So when you look at infrastructure, there is a lot of high capex equipment. And as such, these equipment, these resources, they get shared between the various sites where the metro work is going on. And hence you would see the metro work is being done in parts and pieces. So what is done is when the data is utilized from the geospatial to come up with the plan, and then the resources information is monitored along with it, to come up with what would be the best resource. So like a cement cruncher or a crane, how it should be used so that there's minimal transportation that would be done from one end to the other. And then how would all this come into play gives you an optimal infrastructure experience in terms of the time and commitment. The third very innovative and unique planning where AI has put in a lot of effort is the holistic co-planning. It is also called as the last mile radius. So yes, of course, we're building metros, we're building these subways. But what is also important is the overall planning, because the way the last mile radius is the connectivity of people from their homes to these endpoints. So based on the population of that area, the various roadways in that area, what other resources are required to make the commute faster for the people is driven by AI insights. So that's quite a unique application of AI into the infrastructure EPC region. Moving on, we would move on to the next use case, which showcases how a simple machine, we're talking of cranes, how a simple machine could be converted into smart machines and how they can bring in innumerous value gains. So this is an example which we did for a leading agricultural equipment manufacturer company in India. So they make tillages, and when they make that tillages, it is a manufacturing component of the organization. Manufacturing typically is considered more of a cost center, and how through application of AI, we converted it from a cost center to profit center is what this use case is about. So the tillages, in the plows of the tillages, we have IoT sensors, telematics. So these sensors, as they plow, they are recording very important information about the ground, within the ground. What is the humidity? What is the soil quality? The coarseness, the hardness, the softness, the microorganism. And what is done with this data is quite unique. So what we do is this data from the IoT is converted into human readable form, and this data is then taken on by the manufacturer. It helps them twofold. So first is they are improving their process. They are improving their manufacturing process to see what results we are getting. The second is this data that they captured, they use it for sales. Now, who would be the person who would benefit from this data? Where would this monetization comes in? Who would be the people who would be interested? So fertilizer industry. So if you know a certain piece of land is dry, or it doesn't have enough micro organisms, that means it's a very good area for a fertilizer industry to pitch for. Similarly, the irrigation companies, if the soil is dry, there's not humidity is very low, there the irrigation companies could use that data to determine their sales plan, weather department, and so forth. So this is an application where we took simple steps into what was already built, and we ran through innovation, through sensors, through telematics, through data, brought in monetization, which benefited not just the manufacturer, but if you see, India is an agriculture economy, and the better we do with agriculture, the better it is for our country, and it really value adds from that point of view. Moving on to the next use case is manufacturing. So as we talk about Industry 4.0, we always kind of think manufacturing, industry, all goes together, 4.0, AI, yes, very good. So what we did was, this is a use case which showcases an electric harness that fits into the two-wheeler moped. It's based out of Aurangabad. So what we did for that organization is the organization was facing challenges with their productivity. Every month or every quarter, they would think certain numbers to be met, but that would not be met. What was happening is their machines would break down. And as such, their planning would then go for a toss. So what we helped them with is, on their machine, basic sensors were set. What these sensors would do is they would collect data points on the machine, like a few to name, like temperature, the number of cycles, the frequency. And what we did is, when you accumulated these data, we ran insights to see at what point did the machine break. So we started doing predictive maintenance. As the data would come in, the technology person would monitor this data. And for example, a certain part was not completing a cycle count, means it needed maintenance. So it would go for maintenance during the off time. So how it helped is, the data that we had is the historical data, the various run parameters, and what it brought in is high ROI, because the downtime could be planned. The machine gave you the return on your investment that you were expecting it to. You also made sure that you would deliver the electric wires on time. Now, this is what we were doing, but what also came out of this, which was extremely positive, is we helped them reduce their defect rate. So as we started analyzing their data, the machine data for predictive maintenance, we also took in a drive to look at the defect rate. So there, out of maybe 10 lots, 2 lots went bad. We would look into the data, that what were the parameters at which the machine was running, which produces a bad lot. And that data point sets, insights, the big data, the blockchain records were analyzed to find out the parameters. And then as soon as we reach there, the parts would get fixed or certain parameters would be set correctly. And the results obtained were phenomenal with this. So it brought in efficiency gain, productivity gain, and the most important in today's world is customer satisfaction. Fewer returns, fewer issues, quality product, and which drove in cost optimization. The last use case I would walk into is CAD modeling. So if you look at this time, one of the biggest drive globally is energy and sustenance. So when we are building residential buildings, even in, like, not forget about residential, like manufacturing plants, facilities, everybody wants to go green. Whether it is rainwater harvesting, using reusable construction product, and so forth. So what was happening so far is, you probably have a plan in mind, and you start building the design for it. So what you use is CAD or BMI. So, well, great, that can give you the result. Now, what also happens is, you want to ensure that these buildings are the best designed to bring in sustenance and energy save. So, of course, now the CAD software itself has come up with certain AI components, which the designers and architects are starting to explore. But what we did for a pharmaceutical company in Hyderabad is, for their existing plant, we took their data. And what data that is the infrastructure details. And on top of that, we added some more quantitative and qualitative model that brought in energy efficiencies. Now, in terms of what that quantitative data is, it could be simple things, temperature, the wind direction, the light direction, the occupancy, the area, the weather. So these quantitative data we obtain from the market. We know what performs very well. The CAD model is fed through this, and over it, we do a lot of insight analysis and come up with the best design in terms of what should be the building like, what type of ventilation, what type of lighting, what type of solar panels. So a lot of suggestions would come out from that model. When you talk of the qualitative blueprint, it is quite a unique feature. This is applicable more for when you're building a new building. So when you have the model, you apply the physics modeling component, which can take into consideration the small parts of development itself, like elevations and, at what angle certain beam should be and so forth. Small things which could result in big energy efficient solutions. So basically, through an application of various energy solutions, quantitative, qualitative data, CAD software, we do twinning of the facility. Through this twinning and simulation, we come up with the most green solutions, the smart buildings, which takes into account energy and sustenance. So that is where I wanted to talk about the 4 use cases. And I hope I've introduced certain good things that's been done in the Indian market. And maybe you can take some of these examples, and if there's anything that we can help with analysis, brainstorming, we would be more than glad to do that. And now we have just spoken about the high level what work we did. And I will give the baton now to my colleague Nava, who would walk through how we can take one live example using CAD modeling, which uses optimization and generative design, and we bring in innovation into an organization. So handing it over to Nava. Thank you.
Thank you, Pooja. Pooja, can I have the ball, please?
I did give it to you.
Okay. So welcome back to manufacturing world, everyone. So I would like to take you through a particular scenario in a manufacturing environment. So I want to just give you a brief of the scenario and what I'm trying to illustrate here. So let's assume there is a conversation between a VP of operations of a seat bracket manufacturing company and with her chief design engineer. So during this conversation, the VP of operations has a situation where they have 3 plants shut down due to COVID, and she is striving her maximum to make sure the plants are back up and running. And VP of sales has given her a wonderful golden opportunity right now from an electrical car manufacturer. So electrical car manufacturer, who is one of their customers, wants to increase the efficiency of their vehicles by making them lighter so that they run the extra miles with lesser energy consumption. So with that said, even this particular seat bracket manufacturing company, which is one of their suppliers, has been given that kind of an offer. So that offer is nothing but this VP of operations has been entrusted to make sure they have 2 types of seat brackets, to which they have to reduce the weight of the seat brackets at least by 200 grams. If it's more, wonderful. So if they do that, then they get 5 lakh pieces order by February, that is 2021, to deliver by then. So this means that they will restart their 3 plants and they are back in business. So this is the job that VP of operations would entrust to the chief design engineer, Mr. Madhav. So as usual, the design engineers are pressed for time, and their efficiency is of the key importance in making sure go-to-market is at very high speed and new product introductions happen very efficiently. So here, obvious question from the chief design engineer is when? By when do you need this? And this is where the problem lies. Always the problem is that we always need, market wants everything yesterday. So in this case, the customer has given them just a week time before they take a bid from a competitor. And within a week, they want a prototype that we can achieve this 200-gram reduction or greater with their seat bracket. So of course, chief designer does accept the challenge, but he looks pale because he finds that it's infeasible to begin with. Now, the rest of the thing is, how does the chief designer actually can achieve this using AI? So Madhav goes back, and this engineer recalls one of the real scenarios or real use cases that has been done in India, which is in Ahmedabad, Cubain manufacturing solution, which actually shortened the time and saved cost in manufacturing by casting their bike swing arms using 3D printing, which is additive manufacturing. So they reduced the number of components and they made one piece, and it actually saved them a lot of cost. And it also reduced the time for manufacturing. So this was on the back of his head, but they did not say that they did a wonderful designing or generative designing to make this happen. So this was something that we will discuss here. In a traditional design process, conventional design journey, there is a problem research which is done for the design. Usually there is a problem which is given by the customer, and this has been researched, whether this design is having a proper geometry, whether this will fit the bending moments, all the stress points are correct, all these parts fall in the right place. Is the problem something which is feasible, which is also something which is assessed using finite element methods, or it even can be CAE. All kinds of feasibility analysis will be done, and then risk assessments on the part design will be engaged. Considering all this, once the feasibility is achieved, there are certain set of design parameters which are identified, which are based on the operating conditions that the customer would have specified. This is the operating condition for making this part, and these are the loads or the weights or the stresses at these points, shear stress versus buckle load, whatever it might be. And more importantly, the product characteristics, like the weight, in which case, in this particular case, that's the objective parameter, and that's the objective function which has been asked to be reduced or minimized. And then without sacrificing any other operational characteristics or functionality or strength of the materials or the end assembly, they are supposed to manufacture without exceeding the cost budget as well. They can reduce the cost, but they cannot go up. So this is the mandate. Typical journey involves CAD design, that is a 2D modeling, and then they also do solid modeling. And once the design is finalized, they can optionally do the topology optimization to remove the excess material. Based on an existing design, they do this. And this is where finite element analysis comes into picture to do the topology optimization. And then this goes back to manufacturing. Manufacturing also could say, I do not have the dice to do this. I do not have the right toolkit. My setup changeover times will be excessive if I need to build this. It's not going to be feasible to manufacture this kind of a thing on a long run. It will cost us very high, all those things. There can be redesign, or it can involve tool alteration. It can be die design or die redesign, which can turn into expensive event in terms of time. And then finally, prototype can be delivered. But in this case, assuming an aggressive schedule that the problem research and the feasibility and the design parameter identification, everything can be done by Madhav in 2 days. The CAD design is a manual CAD modeling which is being done, and even though it is computer aided, it is still a design which is iterative. It has to go back to manufacturing, find its feasibility, come back. The redesign can happen, which can add some extra risk of certain days, and then it goes back to prototype production, which typically takes, let's assume, 2 days. I know these are arbitrary numbers in a typical journey, but let's assume in aggressive mode, Madhav is trying to make this happen by pulling an extra line from the shop floor, which is freed up from the regular production to make this happen. Because anyway, there are 3 plants shut down, so they have an ample line capacity to do this. But this takes nearly 10 days, and they lose the order. And not only that, they haven't analyzed more than 1 or 2 designs in this entire time frame. That's it, because they do not have the time to do that. They cannot do umpteen number of iterations to make the design refinements that they actually would ideally need. And it takes 10 days, so this is infeasible. They lose the business. In the AI-enabled approach, in other ways, would include generative designing along with the CAD. So this is the difference. Everything else remains the same from the problem research, feasibility analysis, design parameter identification standpoint. But instead of using the 2D and the 3D CAD design followed by topology optimization alone, they would just need to provide the boundary conditions for the generative modeling software, and also provide the operating dimensions parameters and the design parameters. And not all the design parameters are needed. It depends on how many constraints do you want to load. And the system will give ultimately number of designs might be like in hundreds or thousands, depending on how restrictive our design parameters exist. And these all happen in parallel. And the designer will have the option to go and look at different iterations of design, pick whichever they aesthetically like, and whichever is possible to be built, and then they can send that to the production house, and hence infeasibility risk is removed. But this is replaced with the data strategy need. But still, it's achievable, and it can be achieved in just a day, whatever would have taken otherwise several weeks. This is what generative designing can do to CAD. And data strategy, as I said, is one place where Amplo Global also thrives very strongly. We actually provide this kind of integration solution and also provide data strategy architectures. for various initiatives of this nature. So some of the data that generative designing in this particular case, the software would need, would be, apart from the physical characteristics of the product, you can have the designer can have several factor of safety ranges, which is manually very difficult to do in a CAD model unless you have ample time. They can give a range of factor of safety 2 to 6, and the system will decide what design should be used. They can also provide, I want to make it by only milling, or I want only milling or casting as options, or I'm open to any option, you just give me the design. All kinds of options are possible for providing into the generative design. The system provides umpteen number of options. Production, prototype development and also production can be increased in pace by using additive manufacturing, but that's not necessary here, as we will see further. It can still be with your existing infrastructure on the production line. You can still make advancement in efficiency by upgrading the design process of it. So in this particular case, the time reduced will make them achieve within a week. How exactly does this generative design software actually work? What happens inside it? So let's assume this is a seat bracket, the original seat bracket that existed till date. It has about 1.4 kilograms of weight and a buy to fly ratio of 10:1. That's a huge scrap or a huge amount of yield loss which is happening in the process. It's not necessarily a loss for the company, but because that can be reworked, but it's a process loss. So you buy 10 times the metal to just ship out one time the metal, it's too much. So this also is a dead weight, and that shows that there is feasibility for reduction on weight. So the designer actually will proceed with the 2D design. They make their CAD drawings, and optionally they can also go with the 3D modeling using CATIA or AutoCAD, whatever softwares they have. There is no infrastructure change required. Generative designing comes after that, which actually can be provided by certain softwares like AutoCAD Fusion 360. You have Siemens NX and PTC as Creo. These are some of the famous softwares, not necessarily the only ones in the market. But what all of these do in common is they use certain concepts of deep learning in the AI within it, which is oblivious to the user using it. But some of them are very interesting to note that there is something called as a GAN, or Generative Adversarial Network, which is a neural network, which is very, very interesting in a way. Two different neural networks compete against each other to generate what we need as the end design. So the generator design provides, based on certain abstract algorithms, it uses convolutional network-based designs. And then there is another deciphering network, which actually discriminator network it's called, which identifies whether this is a generated design or it's a real world product model. It tries to classify them. And the goal of the generator network is to fool this particular identification based network or discriminator network. It wants to fool it. So it makes its own design as close to the real world design as possible. And that's how we get the best and most optimal designs out of the entire system by their fights. And finally, the discriminator network fails and it breaks. That's when we get the design out of the software. There are other approaches also for training these kinds of models. These are purely unsupervised learning models in the deep learning. Variational autoencoders is VAE, and pixel recurrent neural network, which actually works two-dimensional space neural network. So I do not want to go into the technical details of it, but you should understand that these products use very complex algorithm of probability distribution comparison within them, and a combination of multiple neural network beyond what I just mentioned into its use case. And that's how, if you put a parameter saying, I want to build this only using casting, it can provide you designs such as this, multiple designs like this. And the designer can pick one which fits the need, like casting has 1.2 kilograms, this particular model. It has a better buy to fly ratio of 4:1. The designer could opt this among another 100 models designs in casting itself that the product could have given. If they say, I do not care which production modeling or methodology I will use, just give me everything. The system is free to provide any kind of design option within the boundary conditions and the operating conditions and the process parameters, and where you can see more optimal models such as 3D printing enabled models, which even can go as low as 0.6 kilograms with 1:1.5:1 buy to fly ratio. So this is very optimal because you have to buy very less material to make each product. That means your inventory cost is reduced greatly. You don't have to pump in so much capital into your inventory to make any products of this nature. So ultimately, what's the gain in using additive manufacturing in addition to the designing software here is that the original seed bracket, as you can see, is comprised of multiple different parts. And now all those 8 different components came into one part. So it's 40% lighter, 20% stronger, no doubt, but the shear stresses and other pieces that work together is gone. Mechanically, yes, it's stronger. It requires a 3D printer, but it's stronger. Now, biggest advantage is you do not need so many suppliers to actually source different components from different places. It increases business resilience, especially in the COVID time. And beyond that, your inventory is shrunk. You just need few components to be stocked, and it reduces your inventory risk. The turns are increased. So there is a lot of benefit. Finally, what did the VP operations achieve here when the design engineer was successful? They increased their process efficiency, which is obvious. The design precision became very superior because these designs could never have been thought out by the designer by themselves, because the product thinks out of the box and it comes up with innovative designs of thousands of numbers from which the designer can choose. And lesser parts, leaner inventory, lesser supplier channels, better resilience, and more importantly, this is a green initiative supporting exercise that the electric car or even a diesel engine or petrol engine cars, fuel efficiency grows. And the energy efficiency in this particular case, more mileage for the same electricity charge, that's a green initiative achieved by lesser reduction of weight. Finally, it's not the most important for us, but for the company, they are back in business. So this is obvious, and it's a good takeaway. Having said all these things, there are still major risk factors in any AI project. And most AI projects have these things that have to be taken care of. And according to Forbes, 76% of the executives report that it's not about the pilot, it's about the scaling of AI that's the problem. The primary most in this is the lack of skills. People's culture has to be very prominently taken care of. And the culture of the organization is the key in order to make any AI engagement very successful. And when culture is neglected, it falls apart. And whatever technology investment, whatever AI brilliance comes in, it will not be successful because of that. This is something very key. And of course, lack of business use case applicability, like trying to invest before you try to figure out where are the pain points and what maximum business value you get out of it, that actually reduces the success rate. I mean, that's one of the major reasons as well. So it's better to know what problems we are trying to achieve and solve, and get the nod from the top level, and also get the bias from all the operational level in terms of empowerment of people, and then go proceed with the technology stack. Once you go into the technology layer, then some companies realize that the data quality is not clear, and data is of very prominent importance. So as far as Gartner is concerned, there was an analytical report which says 56% is for the lack of skills, 42% due to the second reason, and the 34% due to the data quality lack, which is why AI projects typically fail. And we need to be cognizant of these facts in addition to the other two, which I'm coming to you to explain from Amplo's perspective, what we have learned from our implementations of strategy. A lack of proper business strategy is one key foundational reason why the remaining things actually happen. And we will also discuss about the black box effect. But before that, let me talk to you about how to make this risk go away and make it a success factor instead. So in order to gain abundant skills for the people to actually successfully use AI, Amplo has a product, which is a cloud platform called Amplo Fly 4.0, which is first of its kind, where we are trying to productize the entire strategy, which has a module in it called AMP marking, which allows you to actually rate yourself and to make sure that you assess your own maturity as a company, both in terms of culture, technology, knowledge management, various other facets of the strategy. And then you can also get an outside-in view from your competitor and other industries, and then learn from their experience. Typical learning that we have given other customers in this area is that it has to be in the line with the corporate vision. The corporate vision has to be aligned with the people before you begin the AI implementations. And that's the key reason why AI will be successful after that. And that's a change management approach. It has to be driven from the top, but AMP marking gives you a numerical objective verification to do that. Lack of business use case can be replaced with a clear understanding, not just with explaining the business use case or ROI analysis. That goes without saying, but Most importantly, some business problems are so complex, it requires design thinking. It requires more human-centered approach towards the problem solving to mitigate the risk that AI will bring in after it's implemented. And in order to do design thinking, the management has to be having absolute clarity in what their business use cases will be and where are the problems in the entire organization that are supposed to be addressed. Amplify, as I mentioned, has one of the modules for design thinking, which is the first productized design thinking specifically for Industry 4.0 perspective, which can actually help in self-adopting design thinking approach to business use cases. And of course, just the use cases themselves will not solve the problem. There is a low-hanging fruit approach, which I will come to in the strategy portion of it, which is very important for us to keep in mind. The lack of data quality has to be mitigated by data governance properties and then regulatory practices and management practices. It involves data architecture. Data strategy has to be put in place, and not just data strategy from the technical perspective. All the silo barriers in the organization across which data is present has to be brought into single plane of truth. And then there has to be AI ops, which has to be run. That's automation for IT operations, which has to filter the data, make only the filtration of filtered data, which is required for making business decision available for the analytical use cases. Otherwise, we are going to spend a lot of time using junk data and the information will be wrong. So the data governance and regulatory practices, there are a lot of cloud application systems, and Amplo provides data strategy consulting as well, and also implementation of certain technology factors for making this happen. Very important is the lack of proper strategy, which has to be tackled. So when I say strategy, most companies just think that AI will solve all problems. It's actually not that way. They have to follow the money. When I showed you the earlier slide where market research is done, where your focus on individual departments has different revenues and different cost savings, that exactly is what this means. So we have to be having the due diligence. Which department with digitization will yield maximum ROI, where the AI has to be piloted. That has to be a knowledge-driven approach. The value-driven business and operational strategy creation is very key. Look at the product heat map, which Amplify 4.0 generates, or you would have your own heat map across different process functions and process operations, where the maximum pain points exist. Those are the areas where KPIs should be tracked and maximum bang for the buck has to be analyzed and ROI metrics have to be analyzed before you put in your money into the capital infrastructure to get the cloud technology ready and go into the AI. So this is one very key important reason why companies do not follow this and they end up not reaping the benefits that they anticipate. The last but not the least, the black box effect is once you have the entire AI solution implemented, you can still not explain to regulators and the government if they ask you a specific question in some cases. You would say AI engine gave this, they would want to see how exactly it was computed. And that understanding is lacking because of the complexity of the models and the black box nature of certain deep learning models or ML models, which do not allow for that. And that transparency has to be necessary in certain critical missions. And in those cases, the suggestion is when you implement sensors or even IoT devices with products which integrate with them and go digitized, you have to use explainable AI tools where the models actually narrate the textual and graphical information for its assessments and provide you the explanation, which is key necessity for any regulators. So having said this, following all these success factors will abundantly succeed the AI digital initiative and make the companies profitable. So having said this, I would hand it back to the forum for Q&A. Thank you so much.
Thank you, Mr. Navaneeth, for that insightful webinar and your presentation. Now, if you allow, we'll take the question and answer questions from the audience, the attendees. Is that okay?
Sure.
So one of the questions So one of the questions from Mr. Rajendran Sudarsanam is, he's asking, in using AI from an expert company like Amplo, is there a subscription model? Does it mean lock in my customer to one AI vendor?
Can you please reread the question?
So he's asking that is there a subscription model from Amplo if somebody has to perhaps
Yes,
take
yes.
Amplo
Amplo is a
services?
cloud-based SaaS AI platform software. Yes, and it is subscription enabled, and it is a monthly operational model, and it is a 5-module product to be very precise. As I said, AMP marking, and then it goes with capability modeling, which is operational strategy, followed by performance measuring, and then design thinking, and then you can also build strategic roadmaps and what-if analysis simulations. So these are 5 facets of it. It's a subscription product. Yes.
Sure. I'm also happy to share that we have a very senior colleague from L&T Defense participating in the webinar, Commodore Mukesh Bhargav. And in fact, he had put one question before the webinar only through the registration process, where he had asked, how do we integrate existing process still running while we transform to Industry 4.0 processes? Would you please help us with some highlight on that? And I would also like Commodore Bhargav to please ask any further questions he may have.
Sure. So existing processes will have to be first understood and narrated. The value streaming will have to be done. And this is one of the key processing that we actually do in our module 2 of our product, which is the capability modeling. We let the operational leaders actually decipher their existing business processes. Then they have a capability of scoring using our internal algorithm. It scores certain steps of every process on various different parameters, and that would actually render a very interesting heat map where you could actually identify where the problem areas in the process is. And based on those problem areas, our AI engine is going to recommend certain business initiative solutions. And those solutions are going to be something that you can create for performance tracking. And those solutions need not always be AI requirements. It might be a process change even. Whatever is the change management or AI adoption process step, it has to follow this bottoms up approach of narrating your current business process for yourself. Your current maturity level for every process is numerically identified. And then you look at the problem areas where you have the maximum pain, and then you attack those areas using the solutions that this product provides. In addition to that, you could also seek help of certain SMEs in-house in your organization or external. We could also provide, or you could also take it from the market for any fine-tuned suggestion on how to make that solution implemented. So this is a very good question, but it's a necessity to decipher the current process before you approach any reformations to them.
Sure. Thank you. Thank you. I would request Commodore Bhargav that if he has any further question he would like to ask you. I have unmuted you, sir. So if you have anything which you would like to ask, or does it answer your query which you had put in the paper during the registration process?
Thank you, Navneet. I would just like to uh, seek your indulgence. Uh, we've been following the principles of the digital twin in our factories and in our processes, which has been quite successful. What do you feel about, or do you have a similar kind of approach?
So digital twinning is actually based on whatever the use case I just covered. It is a wireframing and a digital equivalent of your physical reality process or equipment, whatever the sensors are integrating with your IoT software. But what we actually as Amplo deal with is at the strategic layer, where we provide you the direction how to make these kinds of implementations a reality and success. Rather than we as a company do not actually come and implement the sensors and the digital twinning. We actually do process twinning on the other side. So we actually take up your business process as a whole and then give you the directions in which you actually need to work on in the sequence. Also, sometimes you might already have your strategy, in which case we would analyze where exactly your metrics are, what are your key performance indicators which have been tracked, and where you can get the maximum revenue growth. It's more about the money or the rupees part of it that you will reap benefit from Amplo directly. In the sense, the IoT part of digital twinning is a great thing, based on which one of my colleagues use cases on the energy side, where the building information management tool also can considers all the digital twin of the buildings itself and lets you optimize the energy based on where the heat factor is more, where the people are present, and it cuts off the air conditioners. All those features are automated and sensors, and this is great. But if this is not returning your necessary ROI within a specific time period, it could be because the people are not well trained to use it, or the infrastructure is too bulky or too heavy and heavy maintenance, in which case the strategy of implementing that should be refined. So that's where we fit in. We come into the process refinement and the strategy portion of the whole gamut of things.
Right.
Thank you,
And to
Navneet.
just
Thank
add
you,
to
Pooja.
it, yeah.
Yeah.
Okay. And just to add to it, CAD design using over it on top of it qualitative physics dynamic, just to ensure if so you're not getting a certain result from a plant, the entire plan needs to be rechecked why it would not be doing that. So insights needs to be run on the data that's available from the facility, and further needs to be analyzed.
Thank you. Thank you, Pooja.
Thank you, sir. I hope it answers your queries.
Yeah, it does. Thanks.
So next question we have from Mr. Alok Bhagwat. He's asking that he's asking that you mentioned machine failures are captured to predict next failure and plan maintenance. Can this be achieved without a machine reaching failure? By example, planning maintenance of a new machine with parameter monitoring and logging of power in place.
So what could be done? There are two things. If it is a new machine, then nowadays there are machine parameters that sometimes even the manufacturers maintain. So we procure that data, and if it is a machine which is quite a generic machine, that data can be used, and which through IoT sensors, it can be started to monitor. We take that data, we run it through our AI ML algorithms, which could predict the health very much. The only thing key here is to be able to receive the data. If the machine is quite standard, which has certain data parameters, history, which the manufacturer would provide it, then it is very much doable. If it is an existing machine, then what happens is we look at the past historical data, and if a certain parameter has gone off, there would be a red flag. So the technical person who's maintaining or looking at the data should be able to read it. So for an existing, it is sure sort it can be resolved, and even for a new machine, as long as you can get the data from the manufacturer or from some other agencies which are using the same kind of machines, it is very much doable. And yes, you can avoid a breakdown.
Sure, thanks. Thanks, Pooja. We actually have quite a few questions from the attendees asking that would you be able to highlight or talk about some examples on how AI applications can be used, especially for automotive industry and the cement industry and the civil engineering. So I think, would you like I'm sure we do not have much time. So do you think that we can cover this now, or can we cover it in the next series of the webinar? Is it possible?
I can probably touch on the civil, because that's what are the use cases we spoke about. And so if you see the use case, which is infrastructure. So when you talk of civil engineering, it is buildings, it is infrastructure, roads, bridges. So CAD, which Nawaz walked us through the detailed plan. So using CAD software and the AI components, which is within that software, you would come up with the best suitable optimized plans for making any building, or basically from an infrastructure perspective, from a manufacturing plant perspective, or a facilities perspective. So the CAD software will give you the topological optimization along with regenerative design. So it offers you that. And on top of that, we can use there's a lot of data available for energies, for sustenance, for monitoring your energy optimization parameters. So those could be used on top of those plans to come up with the best civil engineering plans.
Sure.
And to add to that, to the automotive side of it, PPAP is one of the processes very close to what I just discussed now, and the CAD designing. production part approval process, which is the engineering to manufacturing handshake, which happens typically in the automotive, which can actually greatly be made more efficient, where the supplier and customer collaborative information can be rendered using these generative modeling directly. So we do not have to go through those umpteen number of engineering revisions before we come up to a particular first part. It can rather be automated using these kinds of tools. That's one aspect of it. And of course, what Pooja was talking about, the preventive maintenance, the machines which can be preventatively discovering those defects on the line of the automotive plants, right? I mean, instead of finding out the faults after at the end of the line, if the machine can actually be learned based on image analytics of how the correct part or the correct subassembly on along the different flow lines can have to exist based on the classification models, in particular machine learning models such as classification, K nearest neighbors, or it can be any kind of models which are adopted by the smart factory softwares. We also partner with some of the smart factory companies who actually implement these solutions along with our strategy offering. So those products can actually determine well ahead of time, ahead in the line, that your setup or changeover has to be done, or it's not proper, or the alignment or parameters set in the particular testing chamber or combo tester or wherever it might be, that's not right, or even in a line, the part defects can be analyzed well ahead of time. So these kinds of AI applications actually save a lot of money, in addition to what I just mentioned earlier to this.
Sure.
And for the cement industry, where high corrosive environments exist, there are tools which are readily available for coolants and for the based AI ball and AI coolants and all those kinds of applications do exist, where across the entire plant, a single cooling solutions can also be exist. This is just one of the examples in a cement industry where AI has made very big impacts already.
Sure, thank you. I
And
think
there's one more question which I would probably just would like to talk very briefly about any video analytics implemented. So that is one of the very sophisticated applications in our product. So what we do is we do design thinking. When the organizations require to create a very innovative solution, we perform design thinking, and we'll talk about of what that involves in the next webinars. So we have used video analytics, and what happens is when we go to an organization and they're talking about a process, so sometimes the information that's coming out from the people we interview might not be, because it might depend on their day. So what we look at is we apply AI, we record the videos for the people who speak about it, we record their videos, we analyze the videos using advanced AI algorithms, and we will figure out what would be the bias, what would be the emotions of the person who's speaking at that point. So we have applied video analytics, which you would see in our product, so which is a very sophisticated application. And we can talk about it further.
Sure. Thank you, Pooja. I think I would just also like to add to the question on the AI for automotive manufacturing sector. I think it's not only about the preventive maintenance and the charge, which is limited to AI use in AI for the automotive sector. I think every function AI can be used, which is logistics, supply chain, also moving further on the sales part of it. So I'm sure maybe we can, perhaps do one webinar sometime later in November or sometime, where we can talk about the various applications of AI only for the automotive sector, to tell industry that what all areas that AI can really help in that particular sector. Now, yeah. Now moving on to another question, which I'll take. It says, how deep is the AI penetration in manufacturing industry? Is AI implementation worth for a MSME?
Nava, you want to take that?
Yeah, sure. So yes, MSME have their own limitations, typically in adopting AI with the perception that it requires very high cost initiation. But as you saw in my earlier part of my presentation, the benefits and the profits, the revenues and the margins are very high once you digitize. Having said that, there are a lot of startups which have started giving the cloud platforms for MSME specifically. And I know a couple of Bangalore-based startups which already does this. And these cloud platforms allow these MSMEs to actually subscribe to them and make sure data sharing and all these kinds of analytics can be run on those cloud technologies without having to invest heavily on other broader cloud platforms such as AWS based offerings or Google based offerings as of yet, unless they feel confident that, yes, I am seeing revenue and I want to scale this up. That's when they can move on. So there are some local startups available which actually provide this kind of input. And I would suggest MSMEs have to start doing this before it's too late, because there are studies which already predict that in the next 5 years, if you do not do this, then you will become the laggards, and the laggards don't reap any benefit out of the AI adoption after a certain time period. You have to be in the front runner to make the maximum bang for the buck. So I would say it is, yes, it's very much imperative, and you do not have to spend too much money to start with the AI, because there are some MSME specific cloud technologies available.
Thank you, Navaneeth, for that. One very interesting question that we had, or perhaps I was not aware of this kind of query earlier, which colleague has asked that industry colleague has asked that who the IP will belong to once you generate any after the algorithms, after doing research on specific industry or a company, who the IP belongs to.
So, Pooja, do you want to answer that, or?
Yeah. And so it would belong to the organization for whom we are doing the work. Nava, if
Yes.
anything else you want to add.
I mean, if you are using Amplify 4.0, which already has built-in algorithms, those algorithms, we do have a patent for it. And those run behind the scene. It's within the product, and that gives you a lot of insights in the strategy space. Apart from that, our data strategy and other implementations that we do specific to tailor-made to a customer, the IP that we build would belong to the customer in those particular cases. And that's because the algorithms are already built, they have patents. It's just the application of these algorithms and the logic to make sure these are applied properly to your business problem. That's where we actually fit in. And that IP will belong to the company that we implemented.
Sure, thank you. So another question we have is that how much data do you really need to produce accurate results? Given your experience, do you think the clients generally have this amount of data available with them?
So that is the biggest issue. I will talk specifically on that, on the infrastructure project. Because so what was happening as AI adaptation was coming in to the geospatial planning, we realized there was no data. So what was happening is, to figure out what was laid in those routes, we would have to contact the company which is 30, which they had laid. Maybe some of them had laid it 30 years back. It was a challenge to get to the data. It is getting better. We are collecting data, but the challenge definitely is there with not sufficient data. So now most of the times what you do is you try to get it from various sources. It could be slow, it could be challenging. Also, sometimes based on what industry you're serving, certain data could also be synthesized to come up with the best working parameters for that data, which would include the subject matter expert. They would come in, they would put their brains together, they would put their knowledge together and come up with the best optimal data that would be required to do a planning. But for a certain industry like infrastructure, an SME knowledge would not. You would need to contact those organizations. But yes, data is a challenge. Sometimes it's easier, sometimes it's more difficult to get it.
Yeah, I would like to add to this. Having said that, some use cases you might not have data, like the one that I explained, the generative modeling. It's a new design, it's innovation, and nobody has any prior data except for one or two images of your existing product. So there are ways in the design, in the design modeling, in the neural networks and deep learning, where unsupervised learning is also an option, where the model by itself learns with limited data. Its learning is also based on random seed, and it generates its own models, and that trains itself on its own. And these applications are going to be very hardware intensive, and it uses a lot of GPUs on the cloud hardware, which will which will need some amount of technology investment. And that it's possible, not in all use cases, but in certain use cases, it is possible to do that. So wherever regression or in most of regular statistical modeling is required, data is a must. That's why the data strategy and governance has to be in place. And of course, web scraping and other methods of getting the data has to be done in order to kickstart this entire effort.
Thank you, Pooja. Thank you, Mr. Navaneeth. So I think we still have a lot of questions, but we have already run out of time. Would you like to take another question, if that is fine, or shall we answer them through the email?
We could answer through the email, Nava, right?
Definitely,
Yeah,
yes.
we'll go that route. For any questions pending, we would definitely answer them through an email.
Sure. So I will apologize to the attendees that whose questions we could not take it up given the time limits that we have, but we will certainly come back to you over email, and we'll try to attend to all your queries and connect you with the Amplo Global team. With this, I think we come to an end to the webinar. I would like to thank everybody for joining us, and I'm sure that the webinar was informative for all of you and shall help you to introduce the technologies in your respective areas. Special thanks once again to Amplo Global for their kind support. Thank you all and stay safe.
Thank you very much. Thanks, everybody.
Thank you very much. Thank you, everyone.